Okay, let's look at the guidelines for solving a minimum and maximum problem. Okay, these are the steps we used in the last example. First, you identify all the given, and then you figure out what's to be determined. What are you looking for? The what's to be determined leads you to your primary equation. That's what you want to have maximized or minimized. The third step is find that secondary equation. You want to figure out what was given to you, what hint did they give you that we can solve for a variable. The fourth step is determining the feasibility of domain. Now, when we did the step in the last example where we said, hey, -6 can't be a distance, we knew that was finding our feasible domain. We knew that negatives were not in our domain. And the last step is determine the desired maximum or minimum values, okay, which we plug it back in and we solve for all our variables. Now up here in the left-hand corner, they show you some different boxes just to give you an idea of what happens with the volume of a box as you change your parameters on each one, okay, your length, width, and height here. Now these are all square base, okay, but you can see what happens to your volume, okay. This one has 74 1/4, this one's 92, this one 103 3/4. The biggest one would be this one that we dealt with in the last example, which was the 108. And as you get too wide on the bottom and our height is smaller, the volume actually goes down. Now the next example we're going to look at talks about points on a graph. So our feasible domain this time will include negatives, okay, because you can't have negatives on a graph. It says which points on the graph of y equals 4 minus x squared are closest to the point 0, 2. Okay, so let's look at what we're given. We're given this equation, a parabola that goes down, opens down, it has a negative in the front. We're also given a point, okay? Now we got to figure out what are we actually looking for. Closest to a point means we are minimizing distance. That's what we're looking for, minimal distance. So our primary equation is going to be the distance equation. Remember, distance is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. Now, they plugged this point in for your x1, y1, okay? And they came up with a primary equation. The next thing you want to look for is the secondary equation. Now, the secondary equation is what they gave you here, this equation for a parabola. Okay, y equals 4 minus x squared. Now it's already solved for y, so we're in luck. We don't have to solve it for a variable. We're just going to take it and we're going to plug it in right here for the y. So we take out the y and we replace it with 4 minus x squared. Now let's go over here and do a little work. So this is going to be square root of, they left out a little bit, let's fill it in, x squared plus, here 4 minus 2 gives us positive 2 minus x squared to the second power. Okay, oops, and I didn't put my squared. Let me fix that. Let's fix it. So we have 2 minus x squared to the second power. That means we write that twice and we FOIL it. So we're going to have square root of x squared plus 2 minus x squared times 2 minus x squared. Sorry, it's kind of messy. So that gives me square root of, when I FOIL, x squared plus 2 times 2 is 4. We do first. Outside gives me a negative 2x squared. Inside gives me a negative 2x squared. And the last gives me a positive x to the 4. Now when we combine our like terms, that gives us x to the 4th minus 4x squared plus 1x squared is a negative 3x squared, and then plus 4. So this leads back to this equation. Now we have an equation in terms of one variable that we can take the derivative. So we're going to do f prime of x equals, now we're not worried about the radical, right? Because we're going to be setting it equal to 0, and when what's inside the radical equals 0, then you can solve it. So x to the 4th would be 4x cubed Then derivative of negative 3x squared is negative 6x, and derivative of 4 is 0. This can be factored. We can take out a 2x, and then we have 2x times 2x squared minus 3. Now remember to find the critical values. What we want to do now is set this equal to 0. So let's come over here. We're going to say 2x equals 0. That gives us x equals 0. And then we're going to say 2x squared minus 3 equals 0. That gives us 2x squared equals positive 3. Divide by 2. We get x squared equals 3 halves. And then we're going to take the square root. And remember, when you take the square root, you have a plus or minus. X is equal to plus or minus square root of 3 over 2. We're just going to leave that in radical form. So we have 3 critical values here. All right, if we put them on a number line, the negative square root of 3 over 2 would be on the left. That's, I believe, about a negative, 1.2. The 0 would be in the middle. And the positive square root of 3, which would be a positive 1.2, would be right about here. Now, if we plug in numbers and we test them, if we plug in a negative 2, we're going to come back with a negative number. So it's going to be going down. If we plug in a negative 1, we get a positive number. If we plug in a positive 1, we get a negative number. And if we plug in a positive 2, we get a positive number. Now what happens here is we have 2 minimizations. We are looking for the minimal, okay, not a maximum, so we have 2 right here. And if we plug those back into the original equation, now the reason we're using the original equation, this one up here, is because we need a point on the graph. So let's say I go over here and I do y equals 4 minus, sorry, it's hard to write way over there. Let me fix that. Looks terrible. So I do 4 minus, and let's square it. So square root of 3 over 2 squared is just going to equal 4 minus 3 halves. And that would be 8 halves minus 3 halves, which is 5 halves. Now, if I put a negative square root of 3 over 2 in here, because negative times negative is positive, we get the exact same thing. So my 2 points where it is the closest would be negative square root of 3 over 2, comma 5 halves, and positive square root of 3 over 2. Sorry, my handwriting is terrible on this one. Hard to do when you get to the very bottom of the tablet, and a positive 5 halves. This would be your positive square root of 3 over 2. Now notice that it's a tie, okay? So we have 2 problems that give us a minimum, or 2 points, I should say, that give us a minimum distance for that.